Hi, welcome to IBM Spectrum Protect version 7.16. This presentation will cover what's new in the Server Operations Center, Backup and Archive Client, Space Management for Unix, and the HSM for Windows portion of Spectrum Protect version 7.16. My colleague Sean Sperry will cover the virtual environments and the snapshot functionality in a separate YouTube video. Version 7.16 announced on June 14th and it GA'd on June 17th. The first enhancement on the Spectrum Protect server is a performance enhancement for writing to cloud container pools. We now have the ability to back up data to a local cache and then upload it to a cloud container. And what this will do is it allowed for the data to be written rapidly to a local directory and then fed out to the cloud containers at a pace that the cloud containers can read and write the data. In this way, the backups will complete more quickly, and it allows the writes to the object storage to complete outside of that backup window. Now, the actual performance of the writes to the cloud containers isn't changing. What's changing is just the staging area for the initial write. You can choose to have the data initially stored locally. When it is written to this local cache, it will be encrypted and compressed first and then stored on that local storage. A new process will then move the data from the local storage out to the cloud. So as soon as the chunks are committed, they can be written out to the cloud. And when we write to the cloud, we're writing in an encrypted and compressed format. Under the covers, what's happening is that the container storage pools have defined a local storage cache utilizing the define storage pool directory command. This define storage pool directory command you might recognize from the directory container storage pools. Well, we're now also utilizing the same command to allocate space for a cache that will then feed the cloud containers. You can utilize multiple thread processes to write to the containers. And then once the data is transferred from the directory cache out to the cloud container, it is deleted from the directory cache itself. We support Spectrum Protect server platforms of AIX, Linux, Solaris, and Windows. We support cloud container storage pools that consist of CleverSafe, Swift, IBM SoftLayer, and V1 Swift. The steps to create this directory cache are currently manual. What you'll do is you'll first define a cloud storage pool with encryption enabled. You go ahead and you set up the device class and the server passwords and the database recovery files for encryption, and then you define the cloud storage pool. Next, you'll set aside some space for the local cache by utilizing the defined storage pool directories. And notice here you have the cloud pool as the storage pool that these directories are being associated with. And then you're going to go ahead and update the policies, define clients, associate the clients, and simply back up to that local cache, which will in turn write out to the cloud container. Another new enhancement with version 7.16 is our utilization of Aspera FASP to do node replication and protect storage pool on Linux servers. IBM acquired Aspera last year, and Spectrum Protect is one of the first products to integrate this technology directly into the product. What Aspera FASP does is it optimizes the data transfer across a WAN that might have either latency or packet loss issues. The improvement on how much time will be saved by utilizing Aspera FASP depends on how impaired the network actually is. It could be hundreds of times faster than utilizing TCP/IP. When Spectrum Protect uses FASP, it's utilizing the API, and this API will send the data, and when it sends it, it does utilize SSL and the Aspera AES 128 encryption. And both of these are built in. So it doesn't matter if you have encryption or SSL turned on inside of Spectrum Protect. Just by using the FASP, you will get the Aspera FASP SSL and encryption. We currently support Aspera FASP on Protect Storage Pool and Replicate nodes for next generation container storage pools. It does have to be an Linux source and target server, and they have to be at least at version 7.16. Now the Aspera FASP code is included with the Linux Spectrum Protect version 7.16 software, so you don't have to install any extra code. However, you will be required to purchase an Aspera license for both the source and target Spectrum Protect server. And I will show you how you can get a free 30-day trial. In order to set up FASP, it's very simple. You first of all want to determine if your network will benefit from Aspera FASP. And our estimate is if you have a network that has latency of greater than or equal to 50 milliseconds and packet loss of greater than or equal to 0.5%, that would be a good candidate for Aspera FASP. Networks can vary widely, so even if you have numbers that are lower than these two, you might still benefit from Aspera. However, if your TCP/IP is working efficiently, we do not recommend setting Aspera FASP because you might actually see a performance decline. One thing to note is that by utilizing Aspera FASP, we might be able to take more advantage of the existing physical bandwidth, but we cannot exceed the provisioned physical bandwidth. Next, you'll need to obtain and install an Aspera FASP license. You'll need one for each of your servers, and you can request a 30-day trial by sending an email to alliances@asperasoft.com. You'll want to copy those license files to the bin directory on both the source and target servers. And for Linux, that's the /opt/tivoli/tsm/server/bin directory. And then you'll want to set the permissions for those license files to 755 by utilizing the chmod command. The next thing you need to look at is the default range port. Aspera FASP utilizes 15,100 to 15,199. If these ports are not available, you will need to change the FASP beg port and the FASP import options in the DSM-serve option file. And we do recommend having about 100 ports available for Aspera FASP to utilize. Then finally, in order for Spectrum Protect to utilize Aspera, you will need to either go into the Operations Center and define a new server pair and check the Enable Aspera FASP, or you'll need to update an existing server pair to enable Aspera FASP. If you're using command line or scripts or a scheduled replication or Protect Storage Pool, you'll want to update the Replicate node or Protect Storage Pool commands to utilize transfer method equals FASP. Here's some more information on how to obtain a trial license. You can read the FAQ on this trial license, and you can request those licenses by sending an email to alliances@asperasoft.com and including your company name, address, phone numbers, and the email address of the primary contact. Once you start utilizing these licenses, you will see information messages logged in the server activity log. When the Aspera FASP license is about to expire, we will put out a warning message. If it is not found, we'll put out an error message. And if the license is about to expire in a certain number of days, we'll send out an informational message. We'll also send an error message out once the Aspera FASP license has expired, and we'll send out an informational message about the FASP being the current transfer method. Now, when you do node replication, Aspera FASP may or may not be utilized. The reason for this is that we have an algorithm that tabulates the number of extents that need to be replicated for a given object. And if this exceeds 100 megabyte, then we will transfer it with FASP. However, if it's less than 100 megabyte, we'll utilize TCP/IP. We will log informational messages in both the source server and target server, showing you that replication was started with Aspera FASP. You can also do a query session, and that'll show you the COM method of either TCP/IP or FASP. For the actual parameters, here's the two commands that have been updated. That was the protect storage pool and the replicate node, and the new option is transfer method equals FASP. The default method for transfer method is actually TCP. Here's the two new options that have to do with the range for the ports, and these would be in your dsmserve.op file. This slide shows in the Operations Center how you utilize Aspera FASP. So if you're defining a new node replication server pair, you would go into Storage, Replication, click on plus server pair, and then as you're defining the server pairs, if they are X-Linux servers and they are utilizing a directory container, as well as being at least at version 716, you'll have the option to enable Aspera FASP. For an existing server pair, you could go into Storage, Replication, and then drill down into the details. And here on the Properties page, you can click the Enable or Disable Aspera FASP. Okay, moving on to another new function. Let's take a look at the ability to convert file or VTL storage pools into a directory container storage pool. We introduced directory container storage pools a few versions ago, and the advantage of directory container pools is that there is inline dedupe available for the directory container pool, as well as server-side compression. Previously, customers were not able to move existing data into these directory container pools. But now in version 716, if you have either a file dev class or a VTL storage pool, we can move that data into the directory container pool. The only type of data we cannot convert is your NDMP, table of contents, and virtual volumes. And as we do the conversion, we will compress it with the new LZ4 algorithm. Here's the actual command that does the conversion: convert storage pool, source storage pool, target storage pool, max processes, and duration. Once again, the source storage pool has to be file or VTL. It does not matter if the legacy dedupe or the VTL dedupe is turned on. We will convert that to our inline dedupe. When we start the convert storage pool process, the source storage pool will be made read-only. Now, during the conversion, the data is going to be removed from copy storage pools and active data storage pools. So any of the source storage pools copies that reside in copy storage pools or active data storage pools will be deleted. During the conversion, we're utilizing move data commands underneath the covers. So you will see in the activity log information about the volumes being opened and closed and deleted. You can no longer ingest any new data into the source storage pool, and you can only do intra-pool reclamations and deletions. So the conversion of a large existing legacy storage pool may need to be scheduled over several days or weeks. So in that case, you would create a schedule and make sure that you specify the duration equals parameter. And for this duration, this is how long the process will run each time the schedule is kicked off. We have some other commands associated with this conversion process. The first one is query cleanup and then the pool name. And this will give you details on files that could not be moved. Either they were NDMP or table of contents files, or maybe they were damaged files. We also have the removed damaged and then the pool name and the node name command, and this will go out and actually delete any leftover or damaged files. But prior to running this, we suggest you try to repair those files with either a restore storage pool, a replicate node with recover damaged option, or with the move data command. You can also issue a query conversion, and this output will show you the source storage pool name, the target storage pool name, the amount of data that was present when you started the conversion, the total number of data that's been converted, and the total amount of data that was last converted when the last process was run. We also have added information to the query storage pool command. You'll now see output that shows the conversion as either active, meaning the process is currently running, as inactive, meaning it was started but has not been completed, as the conversion is complete but cleanup is needed, so you have leftover files out there that need to be cleaned up, or as the conversion is complete. If you want to kick off this conversion from the Operations Center, you would go into Storage, Storage Pool, click the Storage Pool, and then click on More and Convert. You'll then be prompted for the container storage pool you want to move it to. You'll be warned about any differences in policies, and then you'll be given the opportunity to set up the duration for the schedule. And here you can see it'll actually give you an estimated number of days it'll take to complete this conversion. Likewise, in the Operations Center, we can drill down into the storage pools. And in this case, if we're looking at the destination storage pool and we look at the details and the summary, you'll see any conversions that are in progress to this container pool. If you drill down into the source storage pool and look at the summary, you will see that the status of that conversion, in this case it's converting, you'll see where it's been converted to, and then you'll have the capacity over 2 weeks, and we will have the data converted showed up as well. Also on the very bottom here, we'll show which days the conversion was run on. If there is unconverted data, you will get an additional tab on the details page called Unconverted Data. That'll show you the files that we couldn't convert, and it'll give you the option to either retry the conversion or to delete those files off. Another new feature in version 7.16 is we will be supporting AIX 7.2 and PowerHA 7.2. An additional update in the Operations Center is that we have updated the design language. The fonts and colors and background picture of your logon page has changed. So here you can see the old Operations Center logon, and here you can see the new Operations Center logon. In addition, if you want to simply copy which version this Operations Center is, you can now do a copy of that information. You don't have to do a screenshot anymore. Also, inside the Operations Center, the header bars have changed, both color and some of the icons. So up here in blue is the old bar, and down here in gray is the new bar. A big enhancement to the Operations Center is the addition of our device management for the tape libraries. This allows us to view the information about the tape libraries, including the status of the library, robotics, drives, and paths. And it gives us the ability to track the availability and usage of drives and tapes. On the initial page, you'll now see in the bottom right-hand corner links to the different volumes and tape drives and devices. You can also access the tape drive by going into Storage and click on the tape devices from the pull down. That will take you to this tape devices page, and this page has all kinds of good information in it. First of all, we have the device class, and we are able to show 2 device classes using the same library on the same server. So for instance, right here we have tape class IBM 03 and NAS, both utilizing the same library on the same server. We do give you a status, which is a summary of the other status columns on the server. We have a library management, which will show if it's a library manager, a library client, if it's an external device, or if there's a dash, that means it's not managed or down level. We showed the drives and we showed the available status of that drive. For instance, are they all online or are two offline? We show the paths, and this is both the driver's path and the library robotic path. And then on this screenshot, I don't show, but we also have information about the robotics, the library type, and the device type. If you do select a library and drill down into details, you will see the summary information. And the first thing on the summary information is the capacity bar. And this shows a calculated consumption rate of storage. And so it's based on an average of the change in scratch tape count over the last 2 weeks. And it'll give you a status of either steady, meaning the scratch tape count is not increasing or decreasing. If the number of scratch tapes is decreasing, we'll show you the scratch supply as a number of days, or as 2 months if it's more than 60 days. If the scratch tape availability is increasing, we'll show a value of more than 2 months. In this section of the summary, we show the private tape usage as well as the scratch tape usage over 2 weeks. If you go into the Properties tab in the Details panel, you are able to update some of the library settings, including mount weight and mount retention. If you go into the Drive section, you will see all the drives for a library, and we don't distinguish about the device class. And from here, you can set the drives online or you can turn them offline. If this was a library client, then both the Summary and Drives tab would simply have pointers to the library manager. Let's change and take a look at some new enhancements in the client and API. The first enhancement is instrumentation tracing. In previous version, instrument performance data was only created with the manual test flag. Now in 7.1.6, both the backup client and the TSM API will collect data by default and store that in the DSM instr.log file. The type of information we'll collect for each of the processes includes the thread's activity names, such as the file IO, data verb, compression, transactions, the average time per activity and frequency, each thread's total activity time, the command that was issued and any options that were utilized, and the summary of the backup, restore, and query commands. You can specify a log name and the size of the file. We have two new options. That would be instr log max and instr log name. The size of the log is by default 25 megabytes, and the name of the log by default is dsminstr.log. You can either change those directly on the command or by setting that in the options file. You can also turn off the instrumentation if you do not want it by simply utilizing the enable instrumentation and then changing the default from yes to no. And once again, that could be set in the client option file or directly on the command. Now, the instrumentation enabled by default should not have any measurable impact on your regular performance. The next new enhancement on the client and API is LZ4 compression. Previously, the client and API used LZW compression. In version 7.1.5 on the Spectrum Protect server, we introduced the ability for server container storage pools to utilize LZ4. This created a little bit of a disconnect. If the client wanted to restore data from a 7.1.5 container pool, it would have to first decompress the data and then send that over the network to the client, because the client could not previously read LZ4 chunks. Well, now the client can read those LZ4 chunks, and it can also compress utilizing the LZ4. LZ4 will be used when a client uses compression with deduplication and the data is being sent to a Spectrum Protect 7.1.5 container pool. If you send the data to a lower version of the server or to our legacy storage pools, then we will continue to use LZW compression. All of the selection on whether to use LZ4 or LZW compression is underneath the covers. However, the client does have the ability to turn off or turn on client-side compression. You will see information on the command line client showing what the compression type is, and you'll also see the Java GUI information window to display what type of compression is being utilized. The recommendation on when to use client-side dedupe and client-side compression is very simple. Compress and dedupe in the same place. If your Spectrum Protect server is 715 or above and your clients are 716 or above, then either use server dedupe with server compression, and that'll give you the LZ4 algorithm, or use client dedupe with client compression, writing out to container storage pools. If your server is at a level higher than 715, but your clients are at an older version, less than 716, then we recommend you use the server deduplication and server compression, and that will give you the LZ4 and the container storage pools. Or have the client dedupe the data, send it to the container storage pool, and let the server utilize LZ4 compression. Not all of our data protection products will be refreshed to the 716 level, but you can still take advantage of LZ4 compression by using the version 716 client API. Okay, and you can read through these what to avoid. When we use LZ4 compression, you'll actually see that it has about an 8% better compression ratio than LZW and about 1.5 to 3.5 times faster than LZW compression. When Spectrum Scale 4.21 announces, we will have support for that for the HSM for Unix platform. Another upgrade on the HSM Unix platform is we are simplifying problem determination. Traditionally, when utilizing HSM, those migrations, those recalls, those reconciliations, they all work pretty transparently. But if there was an error, in order to trace what happened, you had to restart the daemons and turn on the trace flag. And often just restarting the daemons would resolve the issue itself, so you never really could identify the original issue. Well, starting in version 716 of the HSM for Unix client, we've introduced 3 pieces to address that. The first is that our syslogs are introduced to the HSM client. So the syslogs will mainly document the automated recovery activities of the HMS client. We will have important additions to the existing error log capabilities, and we will describe in detail why the recovery was initiated. For instance, was it an operating system or a DMAPI issue? We will automatically dump the internal settings of the DSM Watch daemon, and this contains the DMAPI content at the time of the operating system or file system issue. You can also dump the files manually, and here I list for Linux and for AIX how you would dump those manually. These dump files will be written out to the /temp/HSM directory. The other thing we've updated is the HSM problem determination guide. So we describe some of the new capabilities and give different hints and tips for HSM configuration. Okay, let's take a look now at our HSM for Windows product. A new feature we added is file system cleanup. This feature came out of the fact that a lot of times when we migrate the data over and we have populated the migrated files with all the stub files, those stub files just sit there. The end user doesn't delete the data, and some of those stubs are never even accessed to recall data. However, an end user could accidentally do something like a copy folder that would unintentionally create a out of space condition because a massive recall would be put into place. So a lot of our customers wanted the ability to take unused or old stub files and delete them off the file system, but still have the actual file reside in the Spectrum Protect server as an archive file. In version 7.16, we've created a new job where you can clean up the file system. You'll want to create a job and you'll want to specify as the action, delete the files. Then as an advanced condition, you can filter what type of stubs you want to delete. Maybe it's based on migration status, or maybe it's based upon the last migration time. Once this job runs, it will only delete the stub files out on the production machine. It still keeps the actual file as an archive with unlimited retention inside of the Spectrum Protect server. In addition, we mark these files as a special case and we protect them from reconciliation. And what reconciliation normally does is if it finds that stub files have been deleted, it will also delete off the archive copy. But we know that we have specifically requested that the stubs be deleted, but the archive files be retained. If you just want to get an idea of how many old stub files are out there that are of a specific age, we do have a new command called DSM HSM CLC that will give you a list of how many old stub files are on a volume. So once you've run that cleanup job, we've deleted off the stubs and marked the archive files as special retention. If you wanted to actually recall one of those files, you could now go in and search in the file space, and you could specify the node name, the file space, and any specific information about those files. That will then generate a search result list, and you can then either select individual files or select all of them to be retrieved. This will then take the archive copy and repopulate it on the original place on the production server. If you find you are ready to delete off the archive copies also that are residing in Spectrum Protect, maybe you decide, you know what, if no one's touched those files in 365 days, let's just go ahead and delete them completely. You can then run an additional reconciliation job that will find those files that have been cleaned up where the stubs have been removed, and then you too can remove the copy in the archive inside of Spectrum Protect. Here's where you would click on Reconcile Protected Files, and you would give it how old those files should be, how long since their last recall. Another enhancement in the HSM for Windows product is the ability to search the results lists. Prior to version 7.16, the HSM client records a lot of information about the files that we process, and that information is stored in our listing files. We've had users come to us and say, you know, I'd like to be able to search those listing files and get information about the history of a file, or maybe obtain information, user information about a specific client or end user. So you go into Tools, you can choose Search Listing Files, and either search on the default location or other locations. And here's some of the options you can put out there. I have just covered the new features in Spectrum Protect version 7.16. Be sure to check out Sean Sperry's YouTube video. He will be covering the new features in the Spectrum Protect for virtual environments and the snapshot products that we have. Thank you very much.